Welcome to Elementary Algebra, Chapter 1, Fundamental Operations. The book is by Harold Jacobs. I'm your presenter, Molly Crocker. This material is copyrighted. Chapter 1, Lesson 2. We are going to talk about translating English to subtraction. A nomograph is a diagram, usually consisting of 3 parallel scales used to make mathematical calculations. Well, why are we talking about that? We're going to use a nomograph to demonstrate addition and subtraction. Perhaps you've seen one in some form while learning arithmetic. Look at how the 3 scales are numbered. How are the numbers in the middle scale related to the top and the bottom scale? Yes, they are doubled. How can a nomograph be used to add 5 and 5? Draw a line between 5 in the A scale to 5 in the B scale. The A scale's on top, the B scale's on the bottom. What number does it go through in the C scale? 10. 5 plus 5 equals 10. 2 plus 4 is next. Note that the line that connects these two goes through 6 on the C scale. A line connecting 10 and 7 goes through 17 on the C scale. In arithmetic, I'm sure your teacher told you that if you knew your addition facts, then you also knew your subtraction facts in reverse. If you drew a line from 11 in the A scale to 19 in the C scale and through to the B scale, it would intersect the B scale at 8. Same with 6 in the A scale, connect to 6 in the C scale, and 6 take away 6 would be 0. That's what it goes to on the B scale. Can you write the addition problem and 2 subtraction problems illustrated here? The 3 problems are 3 plus 5 equals 8. I suppose there's 4. 5 plus 3 could also be 8. 8 take away 5 is 3, and 8 take away 3 is 5. Now, let's do this with the scales. The A, B, and C in the second column on the bottom represent the scales from which they are taken. 3 plus 5 equals 8. The number on the A scale plus the number on the B scale equals the number on the C scale. Do you see how the letters represent what's happening with the scales? This is algebra, and we are generalizing what's happening with the numbers by using letters. The last column could be read, if A plus B equals C, then C minus B equals A, and C minus A equals B. Terminology. The result when we add is called a sum. The result when we subtract is called a difference. In both cases for algebra, the parts that are added or subtracted are called terms. And we have to talk. We sometimes have to say a subtraction problem. We seem to have more than a few ways to say subtraction. And since the order matters when we subtract, we need to get the translation done correctly so that the letters and numbers fall in the correct order. In each of these phrases, which number comes first? The difference between x and 3 would be x minus 3. X decreased by 3 is x minus 3. But x less than 3 is 3 minus x. X taken away from 3 is 3 minus x. X subtracted from 3 is 3 minus x. Sometimes we say the difference of x and 3 instead of the difference between x and 3. Be flexible. Here are some more examples. 3 taken away from a number is x minus 3. A number taken away from 3 is 3 minus x. 3 less than a number is x minus 3. A number subtracted from 3 is 3 minus x. And 3 minus a number is 3 minus an x. You might want to take notes here. I'll give you a second to pause the slide. And some more. A number decreased by 3 is x minus 3, and x less than y is y minus x. Note that whenever you see the phrase less than, the part we named first comes after the part we named second. The less than phrase is the one that will trip us up the most. Problem 15 talks about a pair of dice. Each die, that's the singular version of the word dice, is a cube with 6 sides. Each side has from 1 to 6 spots. On a standard die, the spots on opposite sides of the cube will add up to 7. This pair of identical dice shows that. On the left-hand photo, you see the side on the top shows 1, and the other 2 sides of that die show 4 and 2. Turn that die over, and you have 6 on the top and sides 4 and 2 showing. The top sides are opposite each other on a single die, and their spots add up to 7. The same pair of dice is on the right, with its opposite sides showing on the top. 2 and 1 are on the sides of each of those die. Let's talk a little bit more about problems 15. We know the opposite sides of a die add to 7. Let's roll 2 of the dice and see that the sum of the dots is 10. There are 2 ways for that to happen, as we see here. Now, what's on the opposite side of each die, and what is their sum? And what is the sum of the dots altogether? 14 for each pair. Why is that so? Well, the sum of the opposite sides of one die is 7, so the sum of the opposite sides of 2 dice will be 14. What would the sum of the opposite sides of 3 dice be? 3 times 7 is 21. Now let's pretend that we don't know what came up when we rolled 2 dice. One die has x dots and one die has y dots. What's a way to say how many dots we see? We would add them, so the sum of the dots is x plus y. Now, what's a way to say what would be on the other side? If the opposite sides add to 7, then the way to say what's on the other side would be 7 minus x for the upper die, 7 minus y for the lower die. Adding those 2 expressions together gets us 14 minus x minus y, because their sum is 7 minus x and 7 minus y. That would be true no matter how the dice were rolled. We have used algebra to generalize what's happening. In problem 16, Babar is an elephant, the main character in some children's stories that you may have read. If Babar gains some weight, then we would add those pounds to his weight. If he gained 200 pounds, then we would add 200 to his weight of 7,000 pounds. But what's a way to say that Babar gained some weight when we don't know how much he has gained? Well, what do you want to call it when you don't know what it is? Let's say he gained X pounds. The expression showing how much he gained would then be 7,000 plus X. In algebra, we're happy leaving what we don't know as an expression. An expression is something without an equal sign. For now, we're not concerned about what X must be. We are just looking for a way to say that Babar gained some weight. This is a cognitive shift from arithmetic, where we have a number to hold in our hands at the end of an exercise. In algebra, we're going to leave some unknowns as unknown, and along the way, we'll come up with some ways to figure out what that unknown could be. If your brain feels pinched, that's good. If you're having trouble, then work with your instructor. This is translation from English to math, and it takes practice. You need another adult, a parent, an uncle who's really good at math, a cousin who's really good at math, maybe even just a classmate to talk about things. When you're in a country where you don't know the language, it helps to have a good guide. Don't be afraid to ask for help, and don't be afraid to practice your algebra on a fellow classmate. Let's summarize Chapter 1, Lesson 2. The answer when we subtract is called a difference. The parts that are subtracted are called terms. Phrases that mean to subtract include, but may not be limited to, difference, decreased by, taken away from, less than, minus. The English does not always translate to subtraction left to right. The order didn't matter with addition, but it does matter with subtraction. Make sure you know which number comes first. That's all for now.